I'm Anil Kumar. We will take a few questions on displacement and velocity as part of AP Calculus. The question here is, position of an object moving along a straight line in meters is given by s of t equals to t square plus t to the power of 2 over 3, where t is greater than or equal to 0, after time t in seconds. A. Determine the average velocity in first 5 seconds, and B is determine the velocity at t equals to 5 seconds. You can always pause the video, answer the question, and then look into my suggestions. Now part A is determine average velocity in first 5 seconds. Now how do you do it? Well, what we can do is we can see the distance traveled in 5 seconds. So the average velocity, let me write average velocity in first 5 seconds means 0 to 5 seconds. Is that okay? Will be distance traveled, right? Divided by time taken. Correct? So that gives you the average velocity. So distance traveled will be S5 minus S2, right? So that should be S of 5 minus S of 2, 0, right? Divide by time taken is 5 minus 0. So that gives you the average velocity, right? So if I substitute 5 here, what do I get? So let me write down here average velocity, V average, equals to, if I substitute 5 here, I get 5 square plus 5 to the power of 2 over 3 minus 0. If I substitute 0, divided by 5. And that gives me, we can take the calculator and calculate this answer. So that is basically 25 plus 5, 30 to the power of 2 over 3 divided by 5. Right? So that is 30 to the power of, within brackets, 2 divided by 3 bracket close, divided by 5, and that is 1.93 seconds. So that becomes the, meters per second, meters per second, right? Is velocity, average velocity. This is displacement, that is the time. So that is part A. Part B is determine the velocity at t equals to 5 seconds. So velocity is derivative. So we can write velocity is s dash t. So derivative of this expression is 2 over 3 times t square plus t to the power of 2 over 3 minus 1, that is minus 1 over 3, times the derivative of inside function, which is 2t plus 1, correct? So that becomes the velocity of this function, right? Now, as you can see, well, it is important to note here, since this is square, do you see that? And now this one, so displacement is always increasing. Do you see that? It's always increasing. Okay. Now let's get back to this. And that's why we actually didn't bother to see whether the particle is returning or not in this particular case. Okay. Now here, if you see this, we need to find velocity at 5 seconds. So we need not even simplify. Let's replace t with 5. So we get 2 over 3, and that becomes 5 square plus 5 to the power of minus 1 over 3 times 2 times 5 plus 1, correct? In a way, we have 2 over 3. This is 25 plus 5 is 30 to the power of minus 1 over 3 times 10 plus 1, 11. Is it okay? So let's calculate this value. So we have 2 divided by 3 times 11 equals 2 times 30 to the power of minus 1 over 3. 1 divided by 3. Okay, and this is equal to 2.36. So the velocity, instantaneous velocity at 5 seconds is 2.36 meters per second, right? So that is how we could actually solve this displacement velocity question. I'm Anil Kumar, and I hope that helps. Thank you and all the best.